Alright guys, welcome back to Underground Science, and in this video we're going to be talking about Cahn-Ingold Prelog rules, specifically E and Z stereoisomers. Okay, so E stereoisomers, right, or the E naming stands for specifically entgegen, which basically means opposite. And then if we look at what Z stands for, that stands for zusammen, right? And if you see Z, you can think of the same side, right? Same side or together. Alright, and so knowing this, I think we'll learn it best if we just jump into an example right away. So if we see this here, like we've been doing, right, let's number the longest carbon chain with the most substituents, and so that the substituents are on the least number of carbons, right? But that's what we've been doing for alkanes. Alkenes specifically, the double bond gets priority, not the substituents. So you want the double bond to be on the least carbon number when you're numbering the longest carbon chain. So if we number from here, 1, 2, 3, 4, 5, 6, 7, as compared to, what if I did this, 1, 2, 3, 4, 5, 6, 7? If we look at the blue numbering, right, at what carbon numbering is the double bond at and the chlorine substituent at? So the double bond, right, is on carbon number 4, and then the chlorine substituent is on carbon number 5 for the blue numbering. But what about the red numbering? The double bond is at carbon number 3, and the chlorine substituent is also at carbon number 3. So who's lower, 3 and 3 or 4 and 5? 3 and 3, right? So that means we're not going to do the blue numbering, and we're going to stick with the red numbering. Alright, so we're sticking with the red numbering because we had the lower numbers on the lower carbon numbers on the double bond and the substituent. So now that we know this, you immediately have to look. So if you have an alkene, we have to think, okay, is it cis or trans? So if you remember cis, right, if we had a simple alkene like this, cis would be if the two groups on either side of the double bond were on the same side. And trans would be like this, right? If both the groups are on opposite sides of the double bond. But in this case, we're only worrying about two groups. Right, but what about this example? We have to do something different when we have more than two groups on either side of the double bond. Here in this example, right, on this side of the double bond, we have one major group that we need to focus on, but on this side, we have two major groups we need to focus on. So in this case, it would be more correct to use E and Z stereoisomers, since now we're not only worrying about one major group on each side of the double bond. We're worrying about more than that. One here and then two here. Okay, so let's go ahead and go into example first. So for right now, let's ignore the numbering and let's figure out whether this is E or Z, right? If this is the E configuration or Z configuration. So if we just focus on that, you have to remember, look at the alkene first. Where's the double bond? Then choose a side now. All right, and the reason why you choose a side is because in E and Z naming, right, you have to choose the atomic number of the element, the largest atomic number. Okay, so the atomic number that is the largest, and this element will be the highest priority, and we'll see why this is important in a second. Okay, so if we follow this, I'll start from the right side first. So if we divide this with a dotted line, right, this is where you're looking at. So let's do this side first. So on this side double bond, right, what element do you reach first starting from this carbon that's part of the double bond? So if we trace it, right, this is the first element we reach on this side, right? So you can actually divide this into another quadrant, right, another half, like that. So if we're just focusing on this side, right, the first element you reach is carbon, okay? Now you have to go on this quadrant. So what's the first element we reach on this side? Hydrogen. Okay, so let's just write it twice since we're writing in red anyway. Who has a larger atomic number? Carbon or hydrogen? Carbon does. So we said the atomic number that is the largest is the highest priority. So what we can go ahead and do is put an asterisk over here indicating that this side is the group, or this side of the double bond has the highest priority group, which is carbon. Now you only have to go to the first element in this case, right? Because you already won. So if we look at this side now, let's cover this quadrant first. So what's the first element I reach when I come here? Well, the first element is carbon, right? So let's go and write that down. And then what's the first element I reach coming down this way? Is chlorine. So if we write down chlorine here, who has a larger atomic number, carbon or chlorine? Chlorine does. So that means on this side of the double bond, right, the chlorine, right, will be the atom with the highest priority. What's the atom with the highest atomic number, right, compared to carbon? So that means we're going to assign chlorine to be the higher priority group on which side of the double bond? On the left side of the double bond, right? Because we're comparing this group and this group. And on the right side, we said it was this whole group was the highest priority group because carbon is higher than hydrogen in terms of atomic number. So now that you know that, if you look at the asterisks that we put, right, are the asterisks on opposite sides of each other or on the same side of the double bond? It's on opposite, right? So that means this would be an E. We would designate this stereoisomer as an E stereoisomer. So knowing that, we can go ahead and name the whole molecule now. All right, so remember this was our molecule, and now we know it's what? It's an E stereoisomer, okay? And so after that, we already did the numbering on the previous page, right? So we found out that this was the correct numbering pattern for this molecule. Now we just have to figure out the substituents. Well, we have a chlorine substituent coming off the third carbon of this carbon chain, right? So that would be a 3-chloro group or substituent. And that's all we have to worry about, right? And also we have the alkene on the third carbon. So knowing that, we can, with the IUPAC rules, we can name this molecule. What I like to do is just write the E right in the beginning, right? So we don't miss that important part of the name. So if we just get that over with and write the E in parentheses dash, then you just name it like we've been naming all the other alkene example problems in the previous videos, right? So we name the substituents first. So it would be 3-chloro, and then what carbon number is the double bond on? That's also on 3. So it'd be 3, and then how long is a carbon chain? 7 carbons. So that's hept. And is it an alkane or alkene? It's an alkene because you have a double bond, so it'd be 3-heptene. Now you could also, right, according to IUPAC rules, you can also write it like this. So you can also designate E in the beginning like we did, name the substituents first, like we always do, and then instead of saying 3-heptene, you can just say chlorohept, and then designate where the double bond is right here with a dash, 3-ene. Okay, that would also be the correct way to write the name for this molecule above. All right, this is going to be another example of E and Z and alkene naming. So let's go and tackle this. So what do we do first? Let's divide it, right, like we did in the last example to help us name or help us decide whether it's E or C. So this is going to be a great way to divide this so we can focus on each part or each side of the double bond better. Right, so let's start with this side. So starting at this carbon right here, right, that's part of the double bond, and on the right side, so we're focusing on this side, if we start in this quadrant, what's the first atom we reach as we trace along? That's chlorine, right? So we're going to write the atom we reach, the first atom you reach in red. So that's chlorine. Now let's go this side. So let's trace. Oh, the first atom we reach is carbon. So we write carbon here. Now who has a higher atomic number, chlorine or carbon? Chlorine does. So this side, right, chlorine is the higher priority group in the right side of the double bond, on the right side of the double bond. So we asterisk this one. Now let's go on to this side of the double bond, and let's start here. So let's trace. The first carbon you reach, I said the answer. The first atom you reach is carbon, right? And if we trace this part, the first atom you reach is hydrogen. So who has a higher atomic number, carbon or hydrogen? Carbon does. So now, if you look at this molecule, the asterisk, right, the higher priority groups on each side of the double bond, the asterisks are the asterisks on the same side or the opposite side of the double bond? Right, the double bond's here, this horizontal red dotted line, and the asterisks are on the same side. So what does this mean? It means this molecule would be a Z stereoisomer, right? Because it's together on the same side, the higher priority groups. So knowing that, we can name this molecule now. But in order to name this molecule, right, what should we do first is we should actually number the longest carbon chain, right, with the alkene being on the lowest carbon number. So if we start here, right, we don't have to number it twice anymore. I think we can easily tell which carbon numbering would be correct. If we start here, this would be the numbering pattern, right? And we can tell that the carbon, the double bond is on the third carbon number, which will be the lowest as compared to if we started on this side, right? This would be 1, 2, 3, 4. So the double bond would be on the fourth carbon if we started numbering from this side, but on this, if we start from this side, it's on 3. So that means the red carbon numbering pattern is correct, right? So knowing that, now we just name it like we do any other, like we name any other alkenes, right? So what carbon number is the double bond at? A double bond on is 3. What carbon number is the chlorine substituent coming off of? That's 4, so it would be a 4-chloro. And then we also know that the prefix that we would use in terms of numbering the longest carbon chain, which is 7, would be hept. Okay, and we know that there's a double bond here, and this is an alkene, so it would actually be heptene. So knowing this, let's go and name the molecule, right? But before we do, remember in the previous slide we found out that this was a Z stereoisomer. Okay, so we can't forget that. So let's go and write that first, right? So we can not forget to write this, and then you name it like we normally do. So we have a 4-chloro, and then what carbon number does the alkene come on? That's 3. And then how many carbons long is the carbon chain, which is 7, so it'd be 3-heptene because it's an alkene, right? Or as we know, we can also designate the Z in the beginning and similarly write the substituent first. Then we go on to this part of the name, hept, and then instead of finishing it off, we have to designate where the double bond is, but we can do that right here and say -3-ene. And both of these are the correct way in order to identify what molecule this is, right, according to IUPAC. Alright, and that's it for this video. We'll go into more examples in the next video of alkene naming and E and Z stereoisomers. So I hope to see you guys there.